Hello everyone, it's February the 7th, late at night. Let's do this. Ah, what a day. Non-stop. I think I was doing adding some test case, to a Firebase function. I mean, the function itself is not that complicated, but there are a lot of them. Every time I work with Firebase, it's just tons of unexpected issue will rise up. I think it's just how it is. After you haven't worked it for a while, things change, and then your previous setup doesn't work anymore, and just overall frustrating from time to time, right? And also this function queries the database, so I want to make a very comprehensive test case for it. So to build a test case also took some time. All right, anyway, so that's for today. A long day, but let's take a look at the question. It's an easy one. So the goal is to finish this one as soon as possible so we can move on to the second medium question. All right, let's take a look. I've done this 2020. Okay. Oh, don't look at the solution. Come on. Give an integer, repeatedly add all its digits until the result has only one digit, then return it. Huh. Why did I... If you remember, I have two wrong cases. Can you do it without any loop and recursion in O1 runtime? Oh, let's try this. Huh. Could you do it without any loop or recursion? So we're given a value, right? I want to add all the digits together. How can you do it without using a loop? Without using any loop. How? Exactly. How? How do you do it without using a loop? How definitely using a loop. Using a loop is easy, but without any loop. I have hints without any loop. I can do it with loop, but without using loop. Yeah, I don't remember about this one at all. What should I call it? I shall call it num str equals str num, and I should say while len num str is larger than 1, right? If it's larger than 1, then we say num str equals str something. We are going to say sum something for d in num str int d, and then return int num str. Yeah, That's how I will solve it. But to do it without, that means there's some math solution in this. Well, let me take a look. Maybe if I write it out, it'll be clearer. So this is, I mean, this is technically still a 1. I hope I don't have any wrong answer. Yeah, I don't have any wrong answer. So that's an improvement. All right, that is an improvement. So this solution uses loop. I'll call it on. Actually, we can say O log num. Right, just the number of digits. That's what, 50 milliseconds, 40 milliseconds, 51%. All right. Loop. Thus, it does not satisfy the requirement of O1. Wait, O1 space or O1 time? O1 time without loop. All right, so that's a. I don't know if I can find any. I mean, the numbers are from 0. So 0 to 9 will be 0 to 9. 11, 12, 13, 11 all the way to 18 will be 2 to 9. No, 10. Be 1 to 9. Right? 19, 20, 21 all the way to 27. 1 plus 9 is 10. So that's also 1 to 9. There's no 10. 10 will automatically become 1, okay? So 28 all the way to 36. That's also 1 to 9. 28 to 36. How many are there? 0 to 9 is 9, right? 10 to 18 is also 9. 19 to this is 9. This is also 9 values. So eventually we're going to end up 28, right? And then 37 to 45, 46 to 54, 55. Oh, 56. 56 is 11. But back here, right? So we exhaust of 46. That's plus 9, right? That's plus 9. So that's 0 to 9. Now, after this, 55, 56 is going to be this. All the way to, we're going to add it together. 56, 57, 58, 59. 59 is, and then 60. Huh, that's 63. That's also adding 9. So it's always adding, it's always 9. Ah, so next one will be 64. We add 9 will be 73, with 72, right? And then 73, 2, 91. So 91 to 99, right? 91 to 99. We go back. That's 10. That's 18. 18 will be that, right? And now 1 100. I think 100 will be to 108. So that's the trick. So just 0 to 9. So we just do 9 at a time. And we just do the value of mod 9. Right? No, hold on. 0 to 9. Now 0 to 9 is a special case. It's actually 1 to 9. Right? So if it's 0, it's going to be 0. Because that's the only chance it's going to be 0. So if it's larger than 0, it's just going to be 1 to 9. And then 10 to 18. So just divide it by 9. Right? Divide by 9. And the remainder divided by 9. And the remainder, because at the end, these are divided 9, 18, 27, 36, right? So divided by 9, the last one is so 11, let's say 10 divided by 9 is, remainder is 1. That's 1. And if, oh, okay. So are we saying that the solution is going to be return num mod 9, right? Mod 9, if it's 0, if it's 0, we need to return 9. Yeah, so this r equals this, okay? We're going to return return r if return r if r is not equal to 0, if r, right? Else, which is r equal to 0, then we return else 9 if num else 0. Oh, we can add a few more, like say 108. So return 9. So this, I think, is the this is the O1 no loop solution. All right, let's see. I have confidence this is right. 0, 0. 1 to 1 to 9, 1 to 9, 10 to 18, 1 to 9, 19 to 27, 1 to 9, 27, 19, 28 to 36. Right. 9 dot dot dot, and then we go 55 to 63. Right, 1 to 9 dot dot dot, 91 to 99 to 9 100 to 108, 1 to 9 dot dot dot. Thus, all we need to do is num mod 9 and analyze the remainder afterwards. I feel like this is a better explanation to have examples. Okay, let's see if this one's right. Yeah, it's correct. Digital root. Yep, I found it myself. But I guess you can actually do this. Yeah. Power of 10 would expanded it. Ah, very smart. Very, very smart. This is 9, so equals module on both sides. Yeah. Yeah. So the digits equals n mod 9. Yep. Okay. That's good. I like this question. Oh, come on. I have nothing to say about this type of people. I mean, okay, you're doing this is not just for interview. It helps your interview, but overall, it's a way to improve yourself, right? I never see this as a special interview prep. I mean, I don't need the interview now. I might need the interview in the future, but that's not the purpose why we do this. We do this because we enjoy, and we do this because we're not good enough for something even more challenging. I actually read it yesterday, and I didn't know there's a code forces, AT code, right? And I know those. I read those two yesterday, and that was legitimately, you know, competitive programming. It's just like in every area, there are people that are really good at it. It's I always think that I will be good at something, like really good at something, but I never realize this. I'm interested in a lot of things, but I just can't break through the beginner, intermediate level. Everything I just stuck with this. Yeah, I wish I could be better. I thought by practicing doing, LeetCode, doing these program problems, at least I can advance a little bit further in this area, in this hobby. But didn't seem to be. All right, let's take a look at this one. Most frequent subtree sum. Given the root, return the most frequent subtree sum. If there is a tie, return all the values with the highest frequency in any order. The subtree sum of a node is defined as the sum of all the node values formed by the subtree rooted at the node, including, so this one, wait, what are we outputting? All the values with the highest frequency. So when we have subtree sum of this is 5 plus 2 minus 3, which is 4, and 2 minus 3. Right, this one will be 5, will be 2, this is a 2. Ah, I see. I see what this is. Okay. I mean, the computer subtree sum is a when, right? I want to know me, I want to know the sum of this and sum of this added together, that's me. So I can do a recursion to get everything and then counted it, right? And then count it, and then we're done. I hope this is how it is. If that's how it is, it's not too difficult. Good old and I can use the most frequent, right? I can use that. So man, Python is so good, man. Make things so much easier. How can I like live without it? Yeah, I can. I mean, if I want to, I can use um, JavaScript for this, but Python just. I mean, it's not a lot of things I use. Just a few things, right? Just a few things. Some list, right? So what we do is def DFS. We need a node, which is a tree node. It's actually optional. Optional tree node, and we do have to return, right? We do have to return an int. I say if not node, if node, right? If node, not node need to return 0. Okay, and now we have a node. Then we say current sum equals node.val plus dfs node.left plus dfs node.right. Okay, so after we've done this, we're gonna say sum list.append. Oh, I don't have to sum. I can just counter. Yeah, I wonder why you do that. I can just counter current sum, right? Plus equal 1, and then return current sum. So we run dfs on root. After we just return counter dot most frequent. Actually, I'm not quite sure. Come on, counter. Where is the documentation? Here it is. Elements most common. Okay. Oh. All elements in a counter. It doesn't give me, it just give me this. And how am I supposed to know? Well. I guess we just, I don't know. Most common. Give me this is useless, right? So I'm actually now gonna just say max frequency will equal to maximum counter dot values, right? And I'm gonna return key for key v in counter dot items if v is equal to max frequency, something like that. No, we're not gonna test it. Come on. Wait, I need to test over here. Okay. We have number of nodes, so we're gonna test this. Okay, Try this. On, that's on. Yeah. So this one is not difficult. A simple DFS can obtain all the subtree sum. We store the sums directly in a counter, and eventually we return the key of the counter with the highest frequency. On, because tree traversal is on, and finding max is on, doing this is also on. So everything is on, that's 71. Yeah, this is easier than some of the easy questions, but let's see if there are other methods. DFS. I really cannot understand the problem. What happened? Yeah, I think that is the. Wow, we might have the same. Yeah, I think we have the same code. DFS root. Yeah. You have trouble understand question. You gotta be more specific. Like what type of trouble you have. I mean, just saying this way, it's not really helping, man. All right, we done. We done our quota. What do you want? Really, we can actually solve. Let's solve an easy one. All right, this is kind of time. I just hit an easy one. I don't want to hit another medium one. Let's hit an easy one. All right. No, not these ones. I know what they are. I don't want to. Duplicate emails. No. Contain duplicate. What is this? Contain duplicate. Wait, is happy number also SQL? No, has to happy number. If n is happy number is a number defined by the following process. Starting with any positive integer, replace the number by the sum of the squares of its digits. Repeat the process until the number equals 1, where it will stay. Or it loops endlessly in a cycle which does not include 1. Those numbers for which this process ends in 1 are happy. It's untrue if n is happy number, okay? So do this, do this, do this, and it's happy. Huh? Wow, really? You can do that. I mean, it's similar to what we did today earlier, right? We just use the same strategy and see, and then we record these things. Yep. Okay, so 202. You think this one has a math solution too? Well, we're dealing with squares. It's a little bit hard to deal with squares. So we're gonna have scene, right? Scene is gonna be a set. And then, what do we do? Well, actually, the set, we'll put n into it, right? And then, oh, actually, no, because I want to say while n is not equal to 1 or n not in scene. Okay, then scene dot add n, and n equals something for digit in str n and int d times int d. Alright, so we sum this together, going back up, and then when we break out, we say if n return n equal 1. Yeah, I think that shall do. So I have 19, which is true, and 2, which is false. And is happy. Oh, hold on. Then we have endless loop. We do it right with strn, right? strn and then sum together. Oh, it is end. Yeah, we can go. Should be fine. 62. Nothing special here. Just follow the instruction. Actually, I don't know how much this one is. I just want 62 milliseconds, a measly 80% ranking. Alright. Why is only 18%? Who knows? What's the solution? Iterative for sure. Get next. Okay. $243. Oh. Yes. Log in. But how many rounds do we have to go? Once it's below 243, it is impossible for it to go back up above. Oh, really? How? Oh, 3 digits. lose a digit at each step until they're down to 3 digits. So we know that worst of them are cycle. All the numbers under 243. They just, so at most is 243. Each number in the chain that is above 243. Interesting. Detecting if a linked list has a cycle. Tortoise and hare. Oh, nice. Wow, this is interesting. Uh-huh. Oh, yeah. Oh, wow. This is actually very interesting. Finds all the cycles. Wait, hold on. Is anything bigger than 243? I'll go back onto 243. My God. Yeah, I think the most interesting one is this tortoise and hare. Yeah, when you compute the next one, it is. So if you write this, you can do the chase. Good, good one. I like it. But I'm not gonna write a tortoise and hare because I'm tired and I just want to end it right here. This is good enough for this one. Alrighty, that shall be it. I will see you guys tomorrow. Adios.